Hello everyone, my name is Jitritasu Azilana Nelson. Today I would like to share with you about my FYP, which is Isolation and Identification of Fungal Antigens Against Rice and Oil Palm Pathogen. This project is supervised by Associate Professor Dr. Termizi Yusuf.
In Malaysia, rice and oil palm are two types of crops that is very important. Rice for our food and oil palm for our source of income for our country. Both of these plants have another similarity, which is they suffer from economical loss due to the pathogen infection. As for oil palm, the most famous infection is by Ganoderma boninase, caused basal stem root disease. Meanwhile, in paddy, there are two. First is Xenomonas oryzae, which cause leaf blind, and Burkholderia gummi, which cause the panicle blind. The best current solution that we have is that to use the synthetic fungicide or chemical. However, this fungicide can harm our environment and also health. In order to fight the pathogen without harming our environment, many studies have been carried out. So, the aim of this study is to isolate and identify fungal antigens that have biocontrol properties against the pathogen and plant growth promotion (PGP) threats. To achieve this objective, first we need to isolate the soil fungi. Currently, we have 18 isolates in total. Next, we will evaluate the biocontrol activities through dual culture assay, where we will measure the radical growth of the pathogen towards the growth of the isolate. Then, the isolate that show biocontrol activity will further screen to poison food agar assay, where we will measure the growth of the pathogen on different concentration of isolate. After that, we will determine the PGP properties in two parts. The first part, we will quantify the production of PGP, which is indole 3 acetic acid, or also known as auxin, which help the plant to grow, and ammonia. Then we will qualify the solubilization of potassium and phosphate, which is both important for plant. After we identify the fungi with biocontrol and PGP properties, we will characterize the fungi through morphological analysis of the colony and through microscopy. Lastly, we will do molecular identification through PCR, DNA sequencing, and lastly, we will create a phylogenetic tree of this isolate. This research has the potential to reduce the use of synthetic fungicide in the industry. By using the fungi isolate as biocontrol agent against the plant pathogen, we can fight the pathogen without harming our environment and health. At the same time, the plant growth promotion properties will also give benefit to our crops. With this, we can kill two birds with one stone. That's all from me. Thank you for listening.